All right, so we'll be looking at this question, this algebra question that um, regarding the equation of a straight line. So this equation that you see at the top, 5x plus 3y equal 2y minus 7. Now we need to write an equation that is perpendicular to this equation that passes through this point, -5, +6. And so we're going to go right ahead. But there are certain key things that we must remember when we are dealing with equation of a straight line, an equation that is perpendicular to any equation of a straight line that is passing through a given point. Very simple. So let's go ahead and try to look at this. Let's try to remember a few things. Now, if I were to, I'm going to write recall. So we need to remember these things, recall. Now, the standard form of an equation of a straight line is always y is equal to mx plus c, right? Where the m is the gradient and the c is where the straight line cuts the cuts the y-axis, which we call the y-intercept. And so what we want to do at all times is to rearrange this given equation into this form. And then we're going to look at the original equation or formula that is used in simplification or reduction of forming this equation, because there is a formula that this comes from, and the formula goes like this. It's y minus 1 is y minus y1 is equal to the gradient, open bracket, times x minus x1, close bracket. So this equation that you see is what gives birth to this line of, this gives birth to this line. So in order for us to find the equation that is perpendicular to this equation, we must use this formula. And so let's get straight into it. So all we need is just a few information. So let's move on. Right, so the first thing we need to do is to rearrange this equation into the standard form of y is equal to mx plus c. And so what we're going to do is to make y the subject of the equation, or have y by itself. And so we're going to rearrange this equation so that we have y by itself. We're going to group all the like terms. We're going to transpose what we need to transpose so that we have this equation modeling or imitating in the form as this. So let's move on. So we want to have y by itself. So we're going to group all the y's on one side and everything on the other side. So I'm going to move this 5 first, this 5x first. So let's move this 5x first. So we have a negative 5x. I want to get rid of this positive 5x. So I need to subtract both sides by negative 5x. So whatever I do on one side, I do the same thing on the other side. This cancels that, leaving us with this only. All right. And so we have 3y is equal to negative 5x plus 2y minus 7. And remember that we want to have all the y's on one side. So we need to get rid of this 2y on this side. It is a positive 2y. So we need to apply the opposite term to get rid of it, which is negative 2y. Whatever I do on one side, I do the same thing on the other side. That cancels that, right? So we want some space right here. So let me just rewrite this in a way. So what we have is now 3y minus 2y is equal to negative 5x minus 7. And if you look at this carefully, we're actually arriving to this form. If you look at here, because we're going to simplify this, and then these terms are going to imitate the gradient. This x is going to be there, and this c is going to be represented by the constant. But just let's continue to simplify to see what it looks like at the end. So we have 3y's, and we're taking away 2y's from the 3y's. It leaves us with 1y or y. Now, these two can be simplified because they are unlike terms. Therefore, our final answer in rearranging this equation so that it looks like y is equal to mx plus c is looking like this. It's looking like negative 5x minus 7. And if you look at this carefully, it is actually imitating this equation, this standard equation. So the y represents that y. The m represents the negative 5, which is the gradient. This is the gradient of the line. This x is just the x that is in the equation, and this c, which is the constant value, which is the y-intercept, is actually negative 7. And so we would have rearranged that. Now, we have not solved the answer. We have not solved the problem, because what it is asking us, we have not found the answer. We have not solved the problem as yet. What we did was just rearrange this equation that looks so messy. It is so messy, so we tried to simplify it so that it looks in a familiar way of what is the equation of the straight line. And so what the task that we're given to do is to write an equation that is perpendicular to this equation. So this equation gives us negative 5x minus 7. So I give us erase this equation right here. So this is the given equation. So all we need to do now is to come up with an equation that is actually perpendicular to this equation. Now, there are some rules as it relates to writing or presenting or expressing an equation that is perpendicular to any line. But let's try to see what is perpendicular first. So a perpendicular is just simply you having a line looking like this, because you're having a line looking like this, and then we have another one intersecting. So if you look at this carefully, one is going this way vertically, and one is going horizontally. So this is like an opposite way of positioning the lines. So if one is positive, then the other one must be negative, because you're looking at something going down this way and going across. So it's like they are not saying the same thing. So they must be like an opposite, like you're reciprocating something. All right. So the rule is, whenever you're going to write an equation that is perpendicular to any given line, remember, this is line 1, line 2. So let's say the given line was this one, which is line 1. For line 1. For line 2, which be the other line that we're going to form. So this is the original line. Let's say this is the original line. And we need to form line 2, which is the line that is perpendicular to this line, which forms this little picture or this diagram of two lines going across, where you find a right angle right there. So what we need to do now is this. Here's a formula. So we have, if you look at it carefully, we should have two gradients, because if we have one line that gives us one, this is original line, this is gradient 1. So the rule says Whenever we have, we should have two lines that are perpendicular. The two gradients must multiply to give you -1. So we already have one of the gradient, which is the given gradient in the given problem. Now, the other gradient, it should be negative. There should be this one right here, but we do not have it. We cannot write the equation of the straight line that is perpendicular to this if we don't have the gradient, unless they say you don't need it, but usually we need the gradient. And so here's a formula that we're going to use to find the second gradient, right? So let's go ahead and plug this in and do some transposing. So gradient 1 would be the given gradient, which is -5. And then we're going to solve for gradient 2 by making M2, which is the second gradient, the subject of the equation. It's a pretty much of algebra. So let's go. So the equation, it goes like this, is gradient 1 times gradient 2 is equal to -1. And this is just a standard way of representing it. What is gradient 1? So remember that gradient 1 is coming from this equation, which is -5. So we need -5. We're going to take -5, plug it where we see M1 times M2 is equal to -1. I know we can simply solve for M2. So all we need to do, since the -5 is being multiplied by M2, we need to apply the opposite operation to get rid of the -5. So we divide both sides by -5, sorry. -5 cancel with -5. M2 is all by itself. And now what we have right here is -1 divided by -5. The rule says we cancel the two negatives, and so our answer is going to be 1/5. So 1/5 is the gradient of the new line that we're trying to write, that which is perpendicular to this equation that we are trying to express, right? So let's go now. Now, we're basically finished. We're just going to apply the formula that I told you about just now in the beginning. So let's check this out. Now, remember, the formula of any straight line is coming from this. Now, remember, all we need is the gradient, and what we need is a point. And the point that we had was -5, 6, if you remember. That's all we need. We just need a gradient and the point. But what is a gradient? We just found our gradient, which is 1/5. So we just need these information to plug into this formula. And then we simplify it. And then we would have gotten the line that is perpendicular to the original line. So let's simplify this now. So we're using the point, the coordinates, -5, 6, and we're using the gradient, which is equal to 1/5. Let's plug the values in now and see what happens. So y remains the same. No, this is x, this is y. So this is y1, x1, this is y1. So let's plug these values in. So if you look at this carefully, we have for y, we have a 6. The gradient was 1/5. The x doesn't, look, there's a difference between x1 and x. So it's like if I have 5 x's and I'm naming them with subscripts, I say x, this is my first x, I say x1. My second x is x2. My third x is x3. So x1 and x2 are not the same, right? So x and x1 they're not the same. Y and y1 are not the same, so don't get confused. So we just say y1, because this is y1. We have what's this? Minus 5, because we have original minus there, and then we have a -5 coming in. So we must give respect to that minus sign. All right, so then just need more space. I don't want this to look too crowded. So let's go ahead and simplify this now. Very easy. Now, at all times, we are trying to model or arriving at this at all times. Y is equal to mx plus c. We all, because this is the equation of the straight line. This is what we're trying to arrive at all the times when we are asked to write an equation of the straight line. So we try to model this. And the thing is, the thing with math, this is a problem that we need to rearrange, because they're not going to tell you, so here, do this, and it's so easy. They're going to have you doing things. And so we have to get this unorganized equation to organize it so that it looks like this. And that's where the problem comes in. But, well, it's math, so you can't execute anything less than doing work. So let's move on. So let's simplify. It's very simple. All right. So if we were to go ahead now, let's try to fix on this side, because this side looks very messy. Very messy. Let's try to simplify it first. Now, if you look at this carefully, let's find, according to the order of operation, we look at what is in the parentheses first. So let's see what is in the parentheses. So we have two negatives clashing right here. So the rule says when a negative and a negative are clashing, it becomes a positive. And so you're doing good so far. So let's erase this thing right here. And now what we really have is y minus negative 6 equal to 1/5 x plus 5. Now what I'm going to do is to distribute this 1/5 to each term in the parentheses. So I write back my y minus 6 is equal to this. This is going to multiply by that, and then they're going to give us 1/5 times x. In other words, it's actually going to be x divided by 5. Because we have 1 times x give you x. And this 5 is going to remain as a denominator. If we multiply 1/5 by 5, we get 1, because what this is really saying is 1 times 5 all divided by 5, which gives us 5/5, and 5 into 5 gives you 1. And so that gives us 1 right there. So we have 1. Now, what we're going to do now is to get rid of the negative 6 and bring it on the other side, because we want to have y by itself. And so let's get some space right here. So we're going to go at the top right here. So you have, so right here, if we're going to add both sides by 6, because it's a negative 6. We want to get rid of the 6. So finally, we have right here, y is equal to x divided by 5 plus 1 plus 6. And these are like terms, so we can just add them. So you're going to have, we're just going to have positive 7. And this is and now we have the equation of the straight line. This is the equation of the straight line. Now, if they ask you what is the gradient, the gradient would simply be 1/5, which we got from the beginning. If we want to write this in the mx, in the y equal mx, so you can vividly see each term. So the y is right there. The gradient is 1/5. The x is on right there, and the intercept, which is a c, is the 7. And there you go. We just answered that question. Like, we were given a line, an equation, we rearrange it in the y is equal to mx plus c form, and then from that we were given a point. We had to find the gradient to use this formula to find the equation of a line that is perpendicular to the original line. So I hope this helped you, and all the best.